Good afternoon, viewers, and welcome back again to my channel. In this tutorial or in this video, we are going to look at our first question on rigid motion or transformation. So, this is how the questions will look like. Yes. So, we are going to take it step by step so that you also know how to go about it when you have these in your exams. Now, what you can do to help you best is that you can have your graph book with you. Then you can follow me as I do it so that you can also easily practice so that you understand it. Besides, if you have not watched all the videos, I will encourage you to watch them because if you watch them, you know the various transformations because you are going to apply these transformations I've already taught in the previous videos to solve this particular question. So if you have not done that, please you can do it. You can do it so that you have a fair idea on it. You really understand very well so that you can easily follow. You can also do the same. Now, let's start. Using a scale of 2 centimeters to 2 units on each axis, draw on a graph sheet two perpendicular axes, OX and OY, for the intervals -10 to 10 on the x-axis and -10 to 10 on the y-axis. What does this mean? Now, let's look at this 2 centimeters to 2 units. When I say 2 centimeters to 2 units on a graph, what it means is that I've done these graphs before, or everything. I've done everything because I don't want it to waste our time. So when I come, I'll just explain it to you. Down here, don't focus on this one because we come to the. We are looking at the 2 centimeters units. Then I have our horizontal axis and you have our vertical axis. Now, if you have a ruler, in fact, the long rule, you can measure 2 centimeters by placing the zero mark here. Then you measure. You realize that it will come here. You get a 2 centimeters here. From here to here, 2 centimeters. Then from here to here to the 2 centimeters. Because it is 2 centimeters to unit, you label here 2. You can still put your zero mark here, the ruler here, then you measure 2 centimeters to come here. Then name here 4 because from 2 you go to 4. From 0 you go to 2 because we are talking about 2 units, 2 units, 2 units. So the interval or the difference should be 2, 2, 2, 2 throughout. Whilst the centimeters 2 should be 2. So it's 2 centimeters, 2 units, 2 centimeters, 2 units, 2 centimeters, 2 units. Now, if you look at the question very well, there's a perpendicular axis. So let's see. 2 centimeters in on each axis. So it means that on the x axis will be 2 centimeters to 2 units, and then on the y axis will be 2 centimeters to 2 units. So you have 0, 2, 4, 6, 8 going 2 centimeters to units. Then here to 0, -2, that's 2 centimeters throughout. Then on the y axis to what 2 centimeters throughout. So on each of the axes, we are expected to use a unit of 2 centimeters to 2 units. Yes. Now, draw on a graph sheet two perpendicular axes, OX and OY. Yes. Now they are perpendicular because they form 90 degrees. Yes. They are perpendicular because they form 90 degrees. So you see, this Y and this X, they meet here and they form 90 degrees. So we have 90 degrees here. We have another 90 degrees here, making what? Uh, this one perpendicular. So it is perpendicular because here is forming 90 degrees. Okay, so there's a 90 degrees here, there's 90 degrees here. Yes, so that is that. That is that. Okay, now let's continue. Now you have to do what? Now, if you see this axis, axis is plural. You only talk about only one singular axis. Let's say you're only concentrating on the x-axis, then you spell it like this. But when you're concentrating on both the x and y, that's why I say OX and OY. Then the axis will be plural. So if you see this, not a mistake. This is a plural form of axis. So OX and OY. Yes. So that is that. So that's the x-axis and this is what the y-axis for the interval -10 to 10. So you are going to use 2 centimeters to 2 units at the same time -10 to 10. So from here 0 to what -10. So -10 throughout to what 10. Then on the y-axis to -10 throughout to 10. So that is what they mean if they say minus to 10, 10 to 10 on both axes. So that is what it simply means. Now, draw triangle. Please, this means triangle. So triangle SYZ with vertices X, which is 2, 9, Y, which is 5, 9, and Z, which is 2, 4. So you are going to plot. So when I come here, you have to draw triangle SYZ. You have to plot the points x, which is 2, 9, y, which is 5, 9, z, which is 2, 4. Then join x to y to z, and z to x. You can do it in a way, so but whatever you do, you still get the same triangle. Yes. So now, if you look at the graph, you are plotting these points. So if you look at the graph, you see these are points x, y, and z. No, x is what 2. Then we have what 9. Yes, and in fact it is 2, 9. We have 2, 9 there. Yes, so s is 2, 9. This is our x 2, 9. You know how to plot points. Okay, so s is 2, 9. Y is what 5, 9. And z is what 2, 4. So you have plotted these points. Now you join these points together. So join s to y using that. So you are going to join s to y to z, and z to x to form a triangle. That is why they indicated that triangle was x, y, z with these vertices, this, and that. So now we have our triangle. We have our triangle x, y, z. Now let's move to the next one. Draw the image triangle S1, Y1, Z1 of triangle SYZ under reflection in the y-axis, where x maps to x1, y maps to y1, and z maps to what? Z1. What does this mean? Now I want to form our image, our first image. But the image you can get the image by reflecting these points in the y-axis. That's why they are saying x maps to s1. That means that after reflecting this point, the original point x in the y-axis, you get our image, which is x1. Now, after reflecting this, our initial points or y in the y-axis, this point y in the y-axis, then get our image point y1. Then after reflecting this one in the y-axis, which is z, which is 2, 4, then you're also going to get our z1. So that is why I'm saying x maps to x1. So the reflection will be done on this to get this. The reflection will be done on this to get this. The reflection will be done on this to get this. So after that, you're going to get our triangle S1, Y1, Z1. Now, if you have to reflect in the y-axis, what does it mean? So let's see what it means. Now, reflection in the y-axis, the rule is that reflection in the y-axis changes xy to negative yx. Now, I'm going to apply the rule to each vertex. Yes, and vertex here too is what? Singular. Because we talk about this one. These are the one vertex, another vertex, another vertex. If you consider all this one, they are vertices, like they mentioned in the question. Vertices, because they are three. So a plural form of vertex is vertices. So you have three vertices. But if you consider only one, it's vertex. Okay. So that is what we are going to do. So these are the vertex, vertex, vectors. They are vertices. Now, reflection in the y-axis, we are going to apply this one. So negative xy. So let's see what we are going to get. So these are original point 2, 9, 5, 9, and 2, 4. So after reflecting these points in the y-axis, you're going to get negative 2, 9. Here too, you're going to negate the x. So you see this is the negative xy. So you're going to get what? Negative 2, 9, negative 5, negative 5, 9, and negative 2, 4. So these are our x1, y1, z1. So this is what we are going to plot on a graph. So after plotting, what do we get? So this is the reflection. So you have x1, y1, and z1. The x1 is what? Negative 2, 9. Our y1 is what? Negative 5, 9. And our z1 is what? Negative 2, 4. So after doing the reflection in the y-axis, this is what we are going to get. Now, we are done with plotting the first point. We have reflected it in the y-axis, or y7 as the mirror line. You see, the y is 7 as the mirror line. So you see, this is the mirror line. This is the mirror. Yes. And this is the point, and this is the object. After reflecting it in the y-axis, or where y7 as the mirror line, this is what we are going to get. Now, let's move to the third one. Now, third one, draw the image triangle S2Y2Z2 of triangle SYZ under an anticlockwise rotation of 90 degrees about the origin, where S maps to S2, Y maps to Y2, and Z maps to Z2. So here too, we are still doing the rotation on the original point. So these are the points. That's why I say X maps to S2. So if you have to rotate or do the rotation on X1, Y1, Z1, Then here will be x1 maps to s2, y1 maps to y2, and z1 maps to z2. So that means they're going to do the rotation on s1, y1, z1. I get it. But because they are saying draw the image triangle S2, Y2, Z2 of triangle SYZ, it means that you're going to rotate the original point to get the S2, Y2, and Z2. I hope that is clear. So now let's look at how to do the rotation. How is the rotation done? Now, to rotate this one anti-clockwise, the rotation of 90 degrees anti-clockwise about the origin. The rule is that when you have XY, you are going to interchange and negate our Y. So this Y will come to where the X is, and then the S will go back and will negate the Y. So since we are considering our original point, 2, 9, we rotate it and get negative 9, 2. So negative 9, 2 for x2. Then point y, which is what? Initially is 5, 9. So we interchange and negate the y, we're going to get negative 9, 5. Then the last point, which is what? Initially 2, 4. Interchange and negate the y, we're going to get negative 4, 2. So let's go and plot it on a point and see how it will look like. So here, our x2, we are going to have what? Negative 9, 2. Then our y2, we are going to have what? Negative 9, 5. So here we are 5. Yes. So negative 9, they have our 5. Then our z2 is going to be what? Negative 4, 2. So this is our point. Please, you can still be practicing when I am doing it. Or you can look at the question. You can pause it when I go to the question, then you copy everything, then you also try. Then after I confirm to see if you have the same thing, or I check to see if you have the same thing. So we are done with our third triangle. This is plotting the first point, reflection in the y-axis, rotation 90 degrees anti-clockwise about the origin. Now let's go to the last one. What does the last one say? Now draw the image triangle S3, Y3, Z3 of triangle SYZ under an enlargement from the origin with scale factor negative 1, where X maps to X3, Y maps to Y3, and Z maps to Z3. So it's the same thing. You are still using the original point. They haven't changed the point for us. If they have said that change the point to, you're going to do the enlargement using the S2, Y2, Z2, that means that it will be S2 maps to S3, Y2 maps to Y3, Z2 maps to Z3. But because you are still using the original point, if you look at this triangle S3, Y3, Z3 of triangle SYZ, still the original point, still the original point, still the original point. So here, the original point where you do the y-axis, reflection the y-axis. This one, the original point where you do the 90 degrees anti-clockwise rotation, and still the original point where you do the enlargement, negative point. So let's see how the enlargement is done. Now, if you want to enlarge this, then this is what you are going to do. Enlargement from the origin with scale factor negative 1. This is the rule. Multiply each coordinate by negative 1. So you have xy is going to be negative y, negative x, negative y. So it means that I'm multiplying 2 by negative 1. And if you watch the previous video, or if you watch the video on scale factor, you understand it more. Yes. So if you are going to multiply 2 by negative 1, that means that the original point x, which is 2, 9, is now going to be negative 2, negative 9. Since this is positive, when you multiply a negative number by a positive number, you always get a negative number. Yes, so here will be minus 2 minus 9. This is 5, 9, so it will be minus 5 minus 9. This is 2, 4, so it will be minus 2 minus 4. So these are our points, S3, Y3, Z3. So now let's go and plot this one to the points. So the first one, S3, we have minus 2, we have minus 9. It is here. Minus 2, we have minus 9. Then Y3, we have minus 5, we have minus 9. Yes, and if you go there, it's there. Minus 5, minus 9. Then our Z3, we have minus 2, minus 4. So these are our triangles. Yes, so if you check the first one, there's the original point, reflection in the y-axis, rotation through 90 degrees anti-clockwise about the origin, and our enlargement of negative one enlargement to we have it here. So you can also pause the video and try to solve these questions. Now, this is our first question. Then in the subsequent videos, I'm going to solve more questions on this transformation. So stay tuned